day, everyone. This is our junior certificate mathematics lesson. My name is Rewane Khare. The topic of today is indices. With me is a learner from Lenzui Junior Secondary School. Her name is Faith Ngele. She is going to be helping me in our discussion of this topic. Before we can start discussing this topic, let us have a look at the lesson objectives. The lesson objective says writing a repeated multiplication as a power. That is, we are going to have a situation where there is a repeated multiplication and then we'll write that as a power. And then in the process, we are going to express a number as a product of its prime factors. That is, we are going to bring in the concept of prime factors. Now, before we can develop this topic further, let us have a look at what we have in the discussion of this topic. It says, generally, when a number is multiplied by itself any number of times, the expression is simplified by using index notation. That is, when we multiply by a number by itself many times, we can represent that by the index notation to get rid of this long multiplication. And then, for an example, if we have 5 times 5 equals to 25, we can write this as 5 to the power 2. This is the same as 5 times 5, and then this will give you 25. So this is the index notation for 5 times 5. We need to bear in mind that 5 times 5, which is 25, here, the 5 times 5 is what we call the expanded form for 25. So this is the expanded form. The expanded form. So 5 times 5 is the expanded form. And then the 5 squared, this is the index form. Where our 25 here is the numerical value. This is the numerical value. And then we need to also bear in mind that if we have 5 squared being in the index form, the 5 here, this is the base. And then 2, this one that we're having here, this one is the power or the index, or we sometimes refer to it as the exponent. So this is what we have. Now, the objective simply says writing a power in its repeated form. So let us have a look at what we are going to be doing. Right, it says expanded forms into index form. That is, you are given an expression like 2 times 2 times 2 in an expanded form, and then you are expected to represent it in index form. You are to represent this in index form. So how do we do this? This is just 2 to the power. We'll count the number of times the 2 has been multiplied. So 1, 2, 3. We just have to count the number of 2's it has been multiplied. 1, 2, 3, 4. So this is just 2 to the power 4. If you are to write 2 times 2 times 2 times 2 in index form, it becomes 2 to the power 4. We may as well look at the other form, 3 times 3 times 3. And then we are to express this in index form. How do we represent 3 times 3 times 3 in index form? The base is 3 because that's what we are multiplying. And then we are multiplying 3 how many times? We are multiplying 3 times. So this will be a 3 to the power 3. And then, what about this one? 8 times 8 times 8 times 8. The base is 8 because we are multiplying 8 how many times? Here we are multiplying 8 4 times. So this is 8 as the base to the power 4. This simply says multiply 8 4 times. This is what we have. Now let me invite Faith here to chip in our discussion and probably ask a question.
I am Faith, as already been stated. I just want you to elaborate more on how numbers in expanded form are written into index form. I am also not sure of changing numbers from index form to expanded form.
Thank you, Faith. Your question is now, how do we change from the index form to the expanded form? We can always change from the index form to the expanded form. Let's see what we should do. The index form to expanded form. 10 to the power 3. This is the index form. 10 to the power 3 is the index form. Now, how do we write 10 to the power 3 in the expanded form? This will be 10 times 10 times 10. It says multiply 10 3 times. You need to be very careful here. You are not multiplying 10 by 3, but you are multiplying 10 3 times. So it's 10 times 10 times 10. Usually the mistake that you make, you'll multiply 10 times 3, but that's not how it's supposed to be. This is simply saying multiply 10 3 times. So it's 10 times 10 times 10, 3 times. And please keep that in mind. Now what about 7 to the power 4? How do we change 7 to the power 4 into an expanded form? This will be 7 times 7 times 7 times 7. The power 4 here simply says multiply 7 4 times. It's not 7 times 4, no. Multiply 7 4 times. So it's 7 times 7 times 7 times 7. That's the expanded form of the index form 7 to the power 4. And then what about 9 to the power 5? 9 to the power 5. This will be 9 times 9 times 9 times 9, and then times the last 9, because it says there should be 5 9s. So you multiply 9 5 times. This is the expanded form of the index form 9 to the power 5. When you expand 9 to the power 5, you multiply 9 how many times? 5 times. Remember, before we went for a short break, we were discussing a situation where you are changing from the index form to the expanded form. Now, I want to invite you to ask a question so that we can go on with our lesson.
Thank you, sir. But how can one express number as product of its prime factors using the concept of indices per objective?
Thank you, Faith. You are saying now, how do we use the index form to represent numbers in the prime factor form? That's a very good question. The question that you have just asked will help other learners home to learn how we express numbers in the prime factor form. Let us have a look at the example on the board and then express those numbers as a product of their prime factors. We've got the number 70. So your question is, we need to express this 70 as a product of its prime factors, because the concept of prime factors uses indices. So 70 is equals to 2 times 35. That's 2 times 35. Now, your question is, we are to express this 70 as a product of its prime factors. Always, we need to check, are your factors prime numbers? When we check the 2 is a prime number. Now, what about the 35? 35 is not a prime number. So we have to go on till a time when all the factors involved are expressed as prime factors. So this will be 2, which is this one, then times 35. We need to look for a factor, in this case should be a prime factor, which we can go into 35. That is 5. And then 5 times 7 is 35. So 70 as a product of its prime factors is 2 times 5 times 7. And then let us have a look at another example. 56. 5, 6. This is equals to 2 times 14. And then this will be 2 times 14 is not a prime number. So what are the prime factors which will go into 14? 14 is 2 times 2 times 7. 2 times 7 is 14, and then this 2 here is the 2 that we just have there in the first step there. So this will be 2 squared times 7. So the 2 squared here is in the index form, then times 7 there, of course, which is just 7 to the power 1. So this is how you express 56 as a product of its prime factors. It's 2 squared times 7. And then Now, we are to express 56 as a product of its prime factors. This will be 2 times 28. And then 28 is not a prime number. So we have to look for the factors such that they are prime and they can go into 28. This will be 2 times 2 times 14. 2 times 14 is 28. And then we have to go on and say this is 2 times 2. We've got a 14 here. Now, when we write this 14, it will be times 2 times 7. 2 times 7 is 14. And then this will be 1, 2, 3. The base is 2 to the power 3 times 7. So, when you express 56 as a product of its prime factors, it's 2 to the power 3 times 7. 2 is a prime number, 7 is also a prime number. So that's how we express 56 as a product of its prime factors. It's 2 to the power 3 times 7. Let us have a look at another example to illustrate more on this. 120. We are to express 120 as a product of its prime factors. We look for the prime factor of 120. The first prime factor of 120 is 2. Then this is multiplied by 60. 2 times 60 is 120. This then will be equals to 2 times, the first prime number that can go into 60 is 2 as well. So it's 2 times 2 times 30. 2 times 30 is 60. Now, you still have 30 here. Is 30 a prime number? No. So go on and look for the prime factors of 30 as well. So this will be 2 times 2 times, this is 30. So it's times another 2 times 15. 15 times 2 is 30. And then this will be 2 times 2 times 2 times 15 is here now. We have to write this 15 using its prime factor format. So this will be 3 times 5. And then this gives us 2 to the power 3 times 3 times 5. This is how we express 120 as a product of its prime factors. We just make sure that all the factors involved are prime numbers, like we have done over here. I want to believe I've answered your question. I want to invite you once more to ask a question so that we can go on with our discussion.
You have presented the objective so well. I am, however, wondering how we can use this concept of prime factor format. Is it of any use to our learning of mathematics?
Thank you, Faith. Your question is now, how do we use this prime factor form in mathematics? How do they benefit us? Let us have a look at an example here that I'm going to present to have a look at how they benefit us in mathematics. The example says finding the lowest common multiple and highest common factor. Then it says find the lowest common multiple and highest common factor of 100 and 200 using the prime factors. So that's how it's going to benefit us. You can use the prime factor form to find the lowest common multiples and highest common factors. But remember, before you can find the lowest common multiple and the highest common factor, you need to express the numbers into the prime factor form. Then from there, that's when you can find the lowest common multiple and the highest common factor. So the question here is, we are to find the lowest common multiple and the highest common factor of 100 and 200. So let's see how we can work that one out. We'll have to start with 100. Remember, we have to start by expressing 100 as a product of its prime factors. So 100 will be equals to 2 times 50. And then this will be 2 times 2 times 25. This will be 2 times 2 times 5 times 5, which is 2 squared times 5 squared. So we have managed to express 100 as a product of its prime factors. Now from there, you go and express 200 as a product of its prime factors. So how do you express 200 as a product of its prime factors? It's 200 this side. It's equals to 2 times 100. This will be equals to 2 times 2 times 50. And then this will be 2 times 2 times 2 times 25. This is 2 times 2 times 2 times 5 times 5. And when we write this in index form, it becomes 2 to the power 3 times 5 to the power 2. So 200 as a product of its prime factors is 2 to the power 3 times 5 to the power 2. But then we didn't answer the question. We are in the process of answering the question which was asked. It says we are to find the lowest common multiple of 100 and 200. So let us find the lowest common multiple of 100 and 200. How do we find the lowest common multiple of 100 and 200? For the lowest common multiple, you take the numbers with the highest powers. For instance, this is 2 to the power 2. This is 2 to the power 3. Now, we will take the number with the highest power. When we compare 2 to the power 2 and 2 to the power 3, 2 to the power 3 has got a higher power compared to 2 to the power 2. So, we'll have 2 to the power 3, then times. Check. 5 to the power 2, 5 to the power 2. In this case, because this is 5 to the power 2 and 5 to the power 2, we'll take 5 to the power 2. If we had 5 to the power 1 this side and then 5 to the power 2, we'll take the number with the highest power. So in this case, we'll just take 5 to the power 2. And then this is 2 to the power 3 times 5 to the power 2. So the lowest common multiple of 100 and 200 is 200. Because this is just 2 to the power 3 times 5 to the power 2. You can always take your calculator and then find out what 2 to the power 3 times 5 squared is. This is just 8 times 25. And then 8 times 25 gives you 200. This is the lowest common multiple of 100 and 200. Remember how we got it? You simply compare the two numbers. Here we expressed 100 as a product of its prime factors, and then here 200 as a product of its prime factors. Now you compare the numbers in your two given variables. This is 2 to the power 2, 2 to the power 3. Take the one with the highest power, is 2 to the power 3. Then 5 squared and then 5 squared. Here is 5 squared and 5 squared, so we have to take 5 squared. Then from there multiply them. You'll get the lowest common multiple. That's how we get it. We are still answering a question in which we are to find the lowest common multiple and the highest common factor. The first part, which is the lowest common multiple, is what we have discussed. So we'll go on and find the highest common factor of 100 and 200. Let us do that. Highest common factor of 100 and 200. We are going to use the concept of prime factor form to find the highest common factor of 100 and 200. Here, we are going to multiply the numbers with the least powers. For instance, this is 2 to the power 2 times 5 to the power 2. Now, we will take 2 to the power 2 because when we compare 2 to the power 2 and 2 to the power 3, 2 to the power 2 is less than 2 to the power 3. So we'll take 2 to the power 2. So this will be 2 to the power 2 times and then check. We've got 5 to the power 2 and 5 to the power 2 here. So when you compare the 5 to the power 2 and 5 to the power 2, these are just the same. So we'll take 5 to the power 2 and then multiply it with 2 to the power 2. This then gives you 2 to the power 2 is 4 times 5 to the power 2 is 25. And then 4 times 25 is 100. So this is how we find the highest common factor of 100 and 200. The highest common factor of 100 and 200 is 100. That's how we did it. It was simple here because here we found that the highest common factor is 100, which was the number given here, and then the lowest common multiple is 200, which is as well the number that was given. Now, what if we have a situation where the highest common factor or the lowest common multiple is not a number given over there? Let us have a look at that. Let us have a look at a situation where we are to find the lowest common multiple of, say, 60 and 50. 60 and 50. We are to start by expressing 60 as a product of its prime factors. So 60 will be equals to 2 times 30. This will be 2 times 2 times 15. And then this will be 2 times 2 times 3 times 5, which gives 2 to the power 2 times 3 times 5. Right, it's 2 to the power 2 times 3 times 5. That's 60 as a product of its prime factors. What about 50? 50 as a product of its prime factors will be 2 times 25. And then this will be 2 times 5 times 5. This gives 2 times 5 squared. Now, the question is we are to go on and find the lowest common multiple of 60 and 50. So, how do we find the lowest common multiple of 50 and 60? Lowest common multiple of 60 and 50. Lowest common multiple of 60 and 50. Remember, with the lowest common multiple, you multiply the numbers with the highest powers. And then with the highest common factor, you multiply the numbers with the least powers. So this one will be, there is 2 to the power 3, rather 2 to the power 2, and then 2 this side. But we are finding the lowest common multiple. And like I said, when you want to find the lowest common multiple, you multiply the numbers with the highest powers. So we'll take 2 to the power 2. Because when you compare 2 to the power 2 and this 2, we can see that 2 to the power 2 is greater than 2 to the power 1 in this case. So it's 2 to the power 2 times 3 is here. We don't have a 3 this side. So that simply means 3 to the power 3, rather 3 to the power 1 is greater than 3 to the power 0, because in this case there is a 3 to the power 0 there. So this is just 3 times, and then there is a 5 here, and then another 5 here. This 5 is to the power 1, this is 5 to the power 2. So we'll take the one with the highest power. In this case is 5 to the power 2. So what we have is 4 times 3 times 5 squared is 25. And then this will be 4 times 3 is 12 times 25. And then what is 12 times 25? We'll have to take our calculator and then find out what 12 times 25 is. It's 12. It's 12 times 25. Not 2, but 12. It's 12 times 25. And then what do we get? 300. So we are simply saying the lowest common multiple of 60 and 50 is 300. That's the lowest common multiple of 60 and 50 is 300. And then what about the highest common factor? Because this one is the lowest common multiple of 60 and 50. What about the highest common factor of 60 and 50? Remember, when you want to find the highest common factor, you multiply the numbers with the least powers. So it means here we will have 2 times 5. And then this gives 2 times 5 is 10. So the highest common factor of 60 and 50 is 10. That's how we get it. I want to believe I've answered your question. But remember, when you are looking for the lowest common multiple, you multiply the numbers with the highest power. Highest common factor, you multiply the numbers with the least powers, like we have done over here. I want to believe I've covered everything that you wanted to know. But before we end this lesson, let us have a look at what we are expected to cover today. The lesson objective simply says writing a repeated multiplication as a power, which I want to believe we did it. Remember, questions can be given where you are to expand an index form and then express it in the expanded form, or you are to write an expanded form into the index form. And then there is also the concept of prime factors. Here, we use this concept of prime factors to find the lowest common multiple and highest common factor. For lowest common multiple, you multiply the numbers with the highest powers. And then highest common factor, you multiply the numbers with the least powers. That's what you should be doing. I want to believe I have answered everything that you asked. Now, this is all that I wanted to cover in today's lesson. Till we meet again in our next lesson, thank you.